Good evening, and welcome to the latest event in the Sagan National Colloquium. This year, as I hope that you know by now, our theme is OWU, Our World Needs You. And to convince you that you have, those of you who are OWU students, that you have all sorts of myriad, exciting, promising futures ahead of you, we are bringing back alumni to talk about their paths, their pursuits of the mythical balance between passion and employment and job and passion. Oh dear, I just said the same word twice in a sentence. The first several Sagan events have been an unusual format. Tonight is our first event where we welcome an alum who will focus on telling the story of his time at OWU and beyond. Since that is the scope of his talk, I'm not going to introduce Greg and tell you all about his many exciting and fascinating jobs and the many different things he's done with his life post-OWU. Instead, I will point out that he is an incredible example of the blurring of lines between the arts and the sciences, the ability for people to take an interest in multiple disciplines and carry that lifelong interest with them throughout their lives and their professions. I was lucky enough to be able to teach with Greg for 2 years while he was here as a faculty member at Ohio Wesleyan, and am honored that he has come back to share his story. So without further ado.
Well, thank you very much, Ellen, and I'm very, very glad to be here. Ohio Wesleyan has a very special place in my heart and always will, and I'm very happy to be able to share my story of where I am now and how I got there and how Ohio Wesleyan has been a huge impact in all of that. I like to say that I've gotten 2 educations from Ohio Wesleyan, and I'll tell you all about why that is the case. So the title of my talk is Science, Policy, Arts, and Engagement, and I want to start off just kind of saying, so there's the first 2 words right there. No, there's not supposed to be a comma in there. That actually is a thing. Science policy is a thing, and that's where my career is now. And so I wanted to just talk a bit about what science policy actually is so you can understand why I'm working in this field right now. But in order to talk about what this term is of science policy, I want all of you to think about what you actually need to do science. A number of you are studying science right now. A number of you are teaching science and practicing science right now. So those of you that are taking science classes, learning about the different terminology, learning about different facts, equations, etc., how processes work, kinematics, you may not stop to think about what you actually need to practice science later or to teach science. You need to be able to have some kind of mathematical theory, you need to have computers, you need to have different sorts of gadgets and circuits to do things, some kind of maybe different parts of experiments to work on, fun diagrams to work, to look at things, computer code if you're looking at those sorts of things, complex equipment like the scanning electron microscope that is wonderfully in the Science Center. By the way, that's federal funding that helped get that, and that leads me to my next part. That in order to do all these different things, there's a bigger structure that science lives in that connects with society and politics and policy that enables you to be able to take science classes, that enables people to be able to practice science. There's the structure of how science education is done that allows people to learn science from a young age onto an older age. There's infrastructure, buildings, laboratories that have to be in place for certain fields of science to actually be done. There's laws and regulations that talk about what kind of science can be done where, who can have access to science, how science is disseminated, how people actually are able to use certain materials in their scientific research. And then there's federal funding that's involved so that people actually are able to make science their livelihood. All of those pieces around the different parts in the center there need to be in place in order for people to actually be able to practice science. And so science policy is getting at those different parts about how science is actually done, how science is enabled to be done, is able to be done by the people who are actually doing it and the people who are learning it. That also means that scientists are not living in a vacuum of academia or a vacuum of a laboratory somewhere. They are interacting with society in these ways by what they have access to, by what's afforded to them, by what they need in order to practice the science. So that oftentimes means the federal agencies that fund science, like NASA, like the National Science Foundation, the National Institutes of Health. There's stuff from the Department of Education that comes down for education regulations for science education from kindergarten all the way through graduate school. And it also means Congress and the White House, because Congress will control how much funding goes to the agencies, laws that are in place. Of course, the White House has its own strategy for how things should be done, and they have to work with Congress to make sure that laws are actually carried out, that laws can actually, well, become laws. So all these different pieces have to come into play for science to be done. And so there are people that work in the field of science policy that help scientists actually be able to do this. And by the way, if you had asked me when I graduated from here in 2002 if I was going to have a career in science policy, I would have looked at you very blankly, because that was not the plan. And I'm going to tell you about that as we go through. So, again, what is science policy? Now you have a bit more of a context about what this sort of career area, what this focus is. And it comes down to two parts. There's science for policy and policy for science. So the science for policy part is where you have scientists, people that have expertise in some field of science or scientific processes that inform how laws are made and written. So there might be some law that's going into place that focuses on some kind of science or will be affecting something, and they really need scientific expertise to get the law correct, to make sure they're reaching the right people, having the right position, etc. That's like using science to influence the writing of policy. And the policy for science then is laws or policies or regulations that are written that determine how science is done or how science is funded. So there are two different aspects of that. One is information from scientists directly feeding into the process. The other one is how is policy actually saying how science should be done or allowing science to be done. My current job involves both those different aspects, and I think that's a really cool thing. Right now, starting just in January, I work at the National Academies of Sciences, Engineering, and Medicine. Title is Senior Program Officer and with the Board on Physics and Astronomy. So my degrees here are in physics and astronomy when I graduated in 2002. So I'm still working in the sort of field of physics and astronomy, just looking at it from this policy standpoint as opposed to the specific scientific research that's being done. Now, when I said the National Academies of Science, Engineering, and Medicine, they used to be three separate entities that were all kind of linked, but now they're officially linked as one big organization. Yet you have scientists that are elected as fellows and members of the National Academies, and you have staff that are on the National Research Council that actually work with those scientists and other scientists in the community. So I am part of that staff that works with the scientists. And so what does the National Academies do? Well, it brings scientists together to discuss important issues for different fields of science and put out reports and studies and statements that are all supposed to be recommendations to either the scientific community or to Congress and the science funding agencies like NASA and the National Science Foundation. And so you have to convene these committees, you have the scientists talk about the important issues, they come together with some kind of unified consensus as to what they think solutions could be for the issues at hand, and then and then we work with them to write up that into a report and a study and an official statement and communicate that to Congress and the federal agencies and the White House, depending on who the actual audience is. So it really is advising the nation regarding all those different parts, advancing the discussion about how these issues are affecting science, making sure we have these discussions, and linking different science areas where they need to be linked, or policy areas where we connect those new frontiers. I want to explain a little bit more about what I actually do there, and so I'm going to go through a couple of the different aspects. One is, and this is going along with my background in physics and astronomy, so I manage the Committee on Astronomy and Astrophysics. So what does that mean? That means that I help bring together a committee of 14 different astronomers and astrophysicists from across the country that are involved in different areas of the fields, looking at different parts of the science, that have some kind of expertise, some kind of area that sets them apart as some person who should be, that would be good at supplying this information. And they are often kind of looking at the projects coming out of NASA, how things are being done, how the National Science Foundation is funding different projects and programs to see, are these things running in the right way? Are we doing the right stuff as a field to be advancing what we want to be advancing for astronomy and astrophysics, and kind of meeting throughout the year a couple different times to get input from the agencies, get input from Congress where appropriate, if need be, put out some statements or reports saying, looking at certain things, but all about the field of astronomy and astrophysics. And the primary audiences for this are NASA, the National Science Foundation, and the Department of Energy, because all these three different federal science agencies fund different aspects of astronomy and astrophysics. So this is really connecting the scientists with those funding agencies. They hear updates, reports from those different funding agencies on the different projects. They can kind of hold them accountable as need be if things are not quite running to schedule, for example, with the James Webb Space Telescope, which is the successor to Hubble. That will be a really great instrument once it's actually up in space, but there's been some setbacks with budgetary things and things like that. So the scientists that are part of this committee are able to actually ask NASA, hey, what's going on? Can you give us information, give us an updated timeline on things? They're kind of being able to check the funding agencies. So it's connecting the scientists with the bigger picture of how the agencies are interacting, the bigger picture of the national scale of how astronomy and astrophysics is being done. The huge thing that I'm involved with right now that's been set up by the Committee on Astronomy and Astrophysics is Astro 2020, or the Decadal Survey on Astronomy and Astrophysics. So what is this? So every 10 years, the astronomy community gets together to decide what the priorities should be for the next 10 years. They've done this the last several decades. And so there's lots of different conversations that have to happen for scientists to say, these are the questions that we think should be asked and could be answered in the next coming decade. And then from that, what missions should NASA fly? What telescopes should the National Science Foundation build? What probes should go to different moons or planets or other parts of the solar system or beyond that would get at answering those questions, so that they can help lay the roadmap for what the national funding picture should be, telling the astronomy and astrophysics community, this is the area we think you should focus your time and effort and energy on. And the funding agencies, we think you should fund these missions, build these telescopes, because that's going to be, those have the most promise for really advancing our field in the next decade. So there's about 150 astronomers and astrophysicists that are involved in this effort. I am co-directing this study along with a colleague of mine, and there are a number of other staff people that are working on this. But we are right now having meetings talking about what the important science aspects are, talking about ramifications of the different parts, all the different parts that connect with this, how this connects with the funding agencies, leading up to a report write-up that will then be released in 2021. So it's a very long process. Some of the reports are done on shorter scales, but this is really, really involved. And NASA, NSF, the Department of Energy, and actually the Air Force Office of Science Research are really involved in this too, and paying attention, wanting to know what's going on. They can't drive the process. They can help give some guidance at the beginning, but it's really the scientists' study. They can get some input from them, but really the audience is, we want to tell you what we think as a scientific community our priorities are, and have the agencies really act on that. And the agencies have honored that the last number of decadal surveys. And so I'm looking forward to what answers are going to be coming out of that, and then how the funding agencies will respond. And for me, this is one amazing thing for science policy, because it's really connecting the scientists with the bigger picture of what the science community wants to do, how they might want to do it, what resources are available, and asking the agencies for more resources if needed, or giving them guidance as to what they think should be done. And of course, there's going to be some conversation from the funding agencies about what is actually possible. Congress will pay attention to it. the White House Office of Science and Technology Policy will also pay attention to it. So it's going to be a very exciting thing for astronomy and astrophysics once we get those answers. So one other committee that I work on, which is actually a little bit different, is the Committee on Radio Frequencies. So you may not realize this, but we interact with radio waves a lot in everyday life. And this is going to be the only scientific chart I show in this talk, but I have to show it. So it might be hard to conceptualize thinking about what radio waves are as part of the electromagnetic spectrum. So what I want you to think of is think about how if you heat something up, then eventually you can see it start glowing. Okay, yes? So right before it starts glowing, and it's hot but not glowing, it's still emitting light, even though it's not glowing in light that we can see. It's just emitting in a different part of the electromagnetic spectrum that spans a whole different range. So we see only this part right here of the electromagnetic spectrum. There's a whole lot of wavelengths, a whole lot of energy that light can be in. And so we only see a little part of it. There's lots of it that's interacting with us all the time. So that part, that object that you've heated up a bit, but that's hot but not glowing yet, is giving off a lot of infrared radiation. That's the heat. And then if it's not so hot, then it's still giving off light, radiation, just in a different level. And that's the microwave and the radio wave part of the spectrum. And radio waves are really important for a lot of reasons, because in astronomy, we can look at radio waves coming from different objects out in space to understand about their characteristics. Galaxies give off radio waves. Pulsars, which are rapidly spinning neutron stars, give off radio waves. There's a whole lot of information we can learn from the universe in terms of radio waves. Different collections of clouds of gas and dust give off radio waves because there's specific elements in there. Specific elements will give off radio waves when you have certain processes happen inside of them. When you have transitions in the nucleus, for example, or transitions with electrons and protons. So those are really important. And also, weather satellites use radio waves because water vapor, like I said, elements give off specific wavelengths of radio waves. Well, water vapor, as a molecule, gives off radio waves as well. And so weather satellites are looking at the amount of water that's in the atmosphere, how much are in storms. You can use that to really check and see about how bad hurricanes are, for example. So scientists use those tools. Use telescopes on the ground, use satellites in space to monitor different things with radio waves. But what also uses radio waves in that part of the spectrum are your cell phones, television broadcasts, radar, airport scanners, things like that. And so there's this kind of almost competition between the scientific use of the radio part of the spectrum and the technology use that we're used to. And so what this committee actually does in order to help look at that, the scientific use of the radio wave part of the spectrum, is to actually see what's happening with companies and organizations that are using communications, that are using airport scanners, that are using radar, different things, to say, when the FCC, the Federal Communications Commission, puts out a public notice saying that this company wants to operate on this wavelength of light that's in part of the radio spectrum to transmit their data, we can say, this is bad for radio astronomy because the signal you're wanting to use will actually swamp the signal we're trying to find. Same thing with the satellites. You could be broadcasting things and you could be clogging up your signal that the weather satellites are looking at. So this is, the Committee on Radio Frequencies has a very special role because it is one of the very few organizations that can actually file a public comment with the Federal Communications Commission saying, no, don't do this. And they actually will sometimes listen. But it's been very exciting for me to be able to work with this committee in that very specialized role, because it involves a bit more of an advocacy sort of thing, which is a different sort of science policy. I'll mention about how that was my previous part of the career before this job as we get later in the talk. I also had a very exciting trip just last week where I actually got to go out and visit a whole bunch of radio telescopes out in New Mexico. It's called the Very Large Array, and that's because it is actually a rather large array of 27 telescopes. Astronomers can be very fun with their acronyms. So that dish right there is actually 82 feet across. And these 27 telescopes are arranged in 3 different arms that can be stretched out using, by transporting them on railroad tracks or squished together, depending on how they want to operate, what they're trying to look at. So we actually got to go on a tour. We had the committee's fall meeting in that spot, and we brought some representatives from the FCC, the National Telecommunication Information Administration, the Navy, and the National Science Foundation, so they could see in person what these radio telescopes are like. And I actually got to go on top of that 82-foot dish, which was rather cool, I have to say. So that's kind of a synopsis of what I'm doing now and how that connects with the science and the policy aspect of things. But as I mentioned before, when I graduated from here in 2002, I had no idea that I was going to be working in this space. So one thing that I want to get across, and I hope you take away from this, is that life is full of challenges and questions. And it's okay to question yourself and see what it is that you want to do. It's okay to come upon challenges and see how you can overcome them. And Ohio Wesleyan can really help you with navigating all of that. So my first Ohio Wesleyan education, as I've already said, I graduated in 2002, right? So I double majored in physics and astronomy. I can proudly say I'm the last person that could do that, because that year, well, actually technically my sophomore year, they switched so that you can do physics or astrophysics, not both. So I get to have that at least a little bit of a marker for myself. But so I didn't just learn the science of physics, the science of astronomy. I didn't just learn equations and write down planetary objects. I was taught how to think about science. I was taught how to think like a scientist, think like a physicist, learn how to analyze a problem, no matter what problem it was, and think about some kind of creative solution to tackle it, find some way to actually address it, to come to an answer. And so it wasn't just me memorizing things, it wasn't just me doing random homework assignments. Everything I was doing had a purpose for having me learn how physics was done, so that when I came upon new topics of physics, new topics of astronomy, I could adapt my mind to think about it instead of just having to memorize new things and say, oh, how does this fit in with everything else? Because I can still analyze it in the same way. And that's thanks to the education I got here, because that's how the professors here think. They don't think about just teaching you science and not explaining what is happening and why, or how not to analyze it. They really do teach you that. But along with the physics and astronomy, that's not the only part of me. There's a whole lot of other stuff that I was interested in and involved in, and I'm very happy that being here let me do that. So I was very much involved in music when I was here. I was in Sweeney Todd the Musical my freshman year. I was in Choral Arts Society and Chamber Singers all that time. And it was really great for me to be able to do that. My professors were flexible with letting me get across campus to go to the music building, to let me actually go to rehearsal. There was one time when an exam had to be moved so that I could actually perform at a concert. So thankfully my professors were flexible in the physics department to do that. And my music teachers were great in encouraging me to study the music, even though I wasn't a major. And that was really important. I was able to be as involved as I wanted to be because of their support. And I also, of course, took other subjects along the way that really influenced me too. I was able to take a Greek history class, a literature class that focused on Roman mythology and some tragedies, and that really helped influence me too, because I got more practice writing than I did in my science classes. Now, of course, I did get more practice writing for the science classes later with senior project and things like that, but I was able to kind of hone a bit more of the communication of my writing in the literature classes, the history classes that I had. The combination of that really helped me to be a better educated individual, I would say that way. And also, I had a great social time here too. I was able to actually join Chi-Phi and have a number of great friends through that, and a number of great friends that were not part of that too. So part of the whole campus experience really helped to make me who I was. And coming out of undergrad, I was really set on pursuing physics and astronomy. And so I knew right then that I wanted to go to grad school. My professors really helped me with that. I was talking to them all the way through the process about what I wanted to do next. And I decided to go to grad school at Ohio State. And so I did go to Ohio State and got my Ph.D. in the physics department doing theoretical astrophysics. And I found that I was really, really well prepared, especially compared to some of my other peers that came in with me from other universities. So I was able to write back to my professors here and say, hey, look, thank you so much for the job that you did, because now I feel so well prepared that I was able to do a really great job, I think, in my classes and setting myself up for research and going through that program there. And in case you're wondering, but I'm not going to go into details of this, my PhD was on the theoretical particle properties of dark matter and how that related to the universe and cosmology. So something else that I did there, I started off studying music there too, but I was able to actually explore dance there more than I had before. I had done some dance when I was in high school with show choir and musicals and things like that, but I never really formally studied. At that time, there were no dance classes here, or maybe a random one that was offered maybe once every 2 years. So it was never on my radar. I didn't take it. I was focusing on the music. But at Ohio State, I was able to actually take dance, and because of my situation there, it ended up where once I found dance more formally there, I just dove in. I tried to do as much as I possibly could, learn as much as I possibly could. I would do physics in the morning and dance in the evening, and then a switch where I was doing dance in the morning and physics in the evening. So thankfully my advisor there he was kind of hesitant with having me do all that, but thankfully he let me do it. But I was really thankful for that experience and was able to actually join a modern dance company in Columbus called Hickson Dance that grew out of some people I knew in the dance program at Ohio State. So I'm mentioning this because the creative part of me, the performing part of me, is a part of me along with the science. And of course, the creative part and the performing part comes along with the science too. It may not be that so much on the surface. But part of my life has been trying to make sure that I can actually tap into that creative part of me, that performing part of me. And so I'm glad I was able to do that here in undergrad, and also in grad school, though it was a little bit harder to make that all work for grad school. But throughout that time, I managed to stay connected with my mentors here at Ohio Wesleyan, giving them updates about what I was doing. Thankfully, I wasn't too far away, so I could come back and visit and talk about certain things, talk about my research, talk about what was going on, and also just kind of ask them about what should I be doing? What am I doing next? Because as my thought processes for what I was doing next changed. At one point, I thought I was going to be a Research 1 professor. That's what I was going to go to grad school to get my PhD, be a high-powered researcher somewhere, and by the time I was done with graduate school, I realized that that wasn't quite what I really wanted to do. I did realize that I liked teaching, and that I wanted to keep on connecting with the fields of astronomy and astrophysics. And so I was able to, once I finished my PhD, teach at Ohio State in the astronomy department some. But then what was really great is that I was able to be here and teaching. And that's what I call my second Ohio Wesleyan education. So this process of me of thinking about what it is that I want to do, realizing that if I'm going to teach, I want to be in a smaller place, like where I grew up, basically, as an undergrad, and be teaching in that way, interacting with the students that way, as opposed to research university. I'm very lucky that I was able to be here. And I was able to be here for 4 years as a visiting assistant professor of astronomy and physics. And by the way, for the students out there, a visiting professor has an end date. So there's no, you definitely have this time when you're done. And so I had that in mind as this was going, because those life questions were going to be coming up again. But I was able to take advantage of this second education at Ohio Wesleyan as a professor to really change my mindset, educate myself again in a different way. And that's thanks to the professors that are here and the students that were here. So as a visiting assistant professor here, I taught a wide range of physics and astronomy classes, all the way from intro astronomy to quantum mechanics 2 for the physics majors. So totally different audiences. This is when I first started learning about what it means to communicate to different audiences, to people that really know the details and those that don't yet. And so that took a lot of education of myself, just to learn how to do that. And again, my mentors here that now became my colleagues were instrumental in helping me navigate that. In that way, I also was able to help increase the department's engagement with the majors, because I could kind of come from an outside perspective, see where I might be able to engage with the students more. I had some more evening activities for the physics majors to get to know each other and hang out and explore some different aspects about physics they wouldn't otherwise. And also, I worked with Barbara Andrek to change the senior seminar for our students so that they could start actually trying to communicate their research early on to their peers and to the professors so they could get used to talking about science. That's something that I realized in grad school that I needed to learn a little bit more of, and was able to bring that back here and say, if you start just talking about your science, you'll understand it better, because you'll lose us, and then you'll have to figure out a different way to explain it so that it actually is clearer. So being able to increase the engagement with the physics students really helped in that way, and helped the students grow and learn as well. I also had a really great treat to be involved in one of the different course connections that happened here at the time, called Modern Life and Its Discontents. And so what that was that it was a number of faculty from tons of different departments. I shouldn't say tons, so it was like probably 7, maybe 6 or 7 departments that were coalesced around the theme of modern life and its discontents. And so what does that mean? That means in this day and age where we know a lot about stuff, what does that mean for us as humanity to understand our place in everything by knowing all those details? So for example, for me, it was cosmology. Knowing what we think the universe is and what it does, what does that mean for us as humanity to be on this rock here around this sun in the context of everything else? And there were others from history and from philosophy and from literature that were involved, and also from zoology to talk about how evolution plays in all of this. And so it really helped me make more connections between the sciences and between the liberal arts. And the students that were there involved in that class could readily see those, because they could see how we all were interacting and see the connections as we put them in front of them. In my classes, I also ended up engaging, of course, with the non-science majors. And this is where I realized I had a bit more of a passionate area, was trying to get the students that were from outside of science to understand more about how science connected to their lives, even if they weren't going to major in science or if they weren't going to take any science beyond astronomy. And so I took it as a challenge to myself to try to figure out how to engage those students a bit more. So for example, for a final project for my astronomy class, I said, you can all write a report if you want with this many pages, this margin, this font size about some famous astronomer who changed our view of the universe, or you could write a poem, write a song, make an animation, do something else creative that gets that across. And so I actually had students play to their strong suits or whatever they were interested in and produce some amazing, amazing stuff. I had someone who crocheted a solar system, someone who made a digital infomercial about changing your view of the universe, people that wrote poems, people that wrote short stories, people that did paintings, and they all had artistic statements to back up why they did what they did for those different parts. And I could see they were excited about what they had done, and I connected the science a bit more to them and made it more relevant. And that was kind of what I realized I might want to focus on a little bit more. Now, another way I was able to actually connect things, and I hadn't thought about doing this before, I'd been performing the dance, performing in dance performances with Hickson Dance. I've been involved in some performances here while I was professor too, but one thing I was able to do also was start actually using dance to integrate with science to help communicate the science. And that was my first kind of way to combine those two things and really start analyzing myself, how they related to each other, how one could be used to inform the other, and how the processes to create in both those fields are parallel. And thankfully, the science lecture series took a chance on me, thank you Shayla, for me to create a science lecture that involved dancers instead of PowerPoint to talk about the history of the universe. And so I worked with the dance professor who was here at the time, and I worked with the dance majors or dance students that I had danced with before for some performances, and said, hey, will you trust me on this? I really want to try this. I put together a lecture all about the universe from the history of the Big Bang until now, and created choreography, and worked with the dancers to make sure the choreography made sense, because I wanted them to do certain things and like, no, we can't do that, that's not going to work. So it was a creative process for how this actually was built. But I was able to actually do it in the atrium of the Science Center. Thankfully it was filmed, because I'm really glad I have that for posterity. But it was a way for me to talk about science in a different way. The dancers all told me they learned so much more than they would have otherwise, and I had people watching, both from a science background and from a dance background, who said they learned stuff they didn't expect to learn about the other fields. And so I felt that I had done a really good job of trying to communicate in a very different way that way. But as I said, visiting assistant professorship has an end date. And so I had to think about what it was that I wanted to do. Did I want to try to find a professorship somewhere else? Or did I want to try to explore more of this engagement with connecting students, connecting people in science and in other fields to try to think about the importance of science? And well, I decided that if I had the opportunity, I was going to actually keep trying to explore the societal importance of science and communicate that to others outside of science, potentially on the policy front with Congress, people who make policy, et cetera. So I was inspired when I found the application, I was inspired to do this when I found the application for the AAAS Science and Technology Policy Fellowship. So this is a program that takes PhD scientists, brings them to DC and puts them into federal agencies like the National Science Foundation, like NASA, like the National Institutes of Health, to see how those agencies actually deal with science and policy, and to have you contribute your scientific expertise to the policy-making process that they're involved in. There also are scientists that end up working in congressional offices through this, where they become the science staffer for a senator or a representative. So there's those sorts of fellowships or the fellowships with the federal agencies. And this was a way for me to really explore more of that engagement with people that might not have a scientific background but need to know about the importance of science. So I ended up working at the National Science Foundation through this process. And they come up a bunch now, and if you don't know about the National Science Foundation, they are an organization that gives federal funds to all the different sciences, ranging from the social sciences all the way to physics. And so they're a very important organization that scientists apply to, funds for, and they're reviewed by other scientists. They're not just handed out by bureaucrats from on high. They're reviewed by other scientists to say, yes, this is a worthwhile pursuit, you should fund this. And you have people, and that's how you can end up having a scanning electron microscope at a university, because people say, this is going to be really important and impactful for the students that I have here. Can we have money to do this? So it was great for me to actually be there. And I was still working in physics there at the National Science Foundation. So I was actually helping to look at how grants were given out, to help convene some of the scientists, some of the physicists there, to look at some of the proposals that came in to say, yes, we should fund this, no, we shouldn't fund that. There are so many good projects here, but you can only pick a certain amount because of budgetary constraints, so where's our money going to go? What's the best investment that we can make? So I was really involved with that process. But along with that, they wanted someone, and this is why I took the position, they wanted someone to look at how the physics was being communicated from NSF out to Congress and to the greater public. And so I was tasked with kind of like looking at things, looking at how the communication was done, and try to figure out how things could be done better. And this is why I was actually really excited about it, because I could be creative and I could look at this engagement that I had just been exploring before. And also I could be a little fun with certain things. This actually ended up being an official product of the National Science Foundation from a document that I put together about why it's important to actually talk about science and communicate science to people outside of your field. So this was targeted to those that get money from the National Science Foundation, the scientists, to do that, to say, yes, it is important to talk about your science to people who don't know what it is you're talking about, and you should really be doing that. So I had a lot of fun putting that together, and it was a really great national scope thing for me to be working on for the importance of the communication of science and engaging with everybody. I also was able to pursue more of the arts aspect also because I started a small group. There are a bunch of small, what we call affinity groups with the fellowship that focused on different aspects. There was not one that connected art and science. And I started one with a friend of mine I made there. We called it START, Science, Technology, and Art. And we met periodically, had some events and things like that to really investigate things, had people from the National Endowments of the Arts talk to us about what they did for grants processes. It was great for me to learn about kind of arts policy too with that way and help me to connect things a bit more. But, of course, there are all these questions about life that I still had, and especially because this fellowship was a 2-year fellowship. So now it was like, okay, what do I do next? Do I want to, and part of this was an experiment for me to see, did I want to keep working in policy? The answer was yes. I was excited by what I did at the National Science Foundation. I wanted to keep on finding something I could do that would be still in that sphere. So while I was assessing what it is that I was actually doing, trying to figure that out, I came upon the American Physical Society, which is the main professional society for physicists. So there are about 50,000 physicists nationwide. They have some international members as well. And I was able to join their Office of Government Relations. Oops, thought I had advanced that. So the American Physical Society Office of Government Affairs, what does that do? It helps scientists to actually advocate to Congress about the importance of physics and why physicists need certain things. So this goes back to what I was talking about the beginning, about the science policy aspect and what you need to actually do your science. So being in charge of the grassroots advocacy efforts, that meant that I was a lobbyist, by the way. I actually did register as a lobbyist for the 3 years that I worked at the American Physical Society in this role. I helped coach physicists to actually talk to Congress about the importance of their science. And again, this involved me being able to communicate to different audiences about the importance of science and about the important aspects of physics and how it connected with the senators and representatives. So all that different education along the way has been building up for being able to write, being able to communicate, being able to think about science in a certain way, to be able to also communicate that to my fellow physicists to say, can you please go to your senator and your representative and tell them why the research you're doing is important and affecting people outside of science in your state, in your district, and why, therefore, the national funding you receive from the National Science Foundation or from NASA or the Department of Energy is extremely beneficial. And that was really impactful for me, to be able to be that person, to go into meetings with either senators or representatives themselves or the staffers and have the scientists be able to communicate that. Or lead staffers from those offices around at poster sessions to students and have students talk about why they did what they did. And by the way, it was funded by a research experience for undergraduates grant from the National Science Foundation that they did on summer research at a university that was in their senator's state. And without that, they wouldn't have had that research experience. So all these different impactful stories I was able to help the scientists tell. But, and one other important thing, I was still able to be creative, and I actually convinced my boss and the outreach department of the American Physical Society to create a monthly video series about science policy, about physics policy. Basically being me talking to the members, the physicists across the country saying, here's what happened the last month. These issues are important. You should take action on this issue. This is why this matters. You should be an advocate for this. Here's what's happening in Washington, D.C. You should be paying attention. And the fact that they let me do that and explore that creative aspect was very important to me. And I heard from many people that they found this as a very important resource, and were having different conversations in their departments than they would have otherwise because they didn't know about these issues that were affecting them. So while this job didn't have an end date, unlike the other ones that I'd had up to this point, towards the end of like 2.5 years, I kind of started wondering, what should I be doing? What could I be doing? Is this where I want to be? Because I found myself, while I was really excited about being able to talk about these impactful messages, one thing that I was feeling very removed from was my interest in astronomy and astrophysics. So while, of course, astrophysics falls under the American Physical Society's purview, we didn't talk about it that much. And I was talking about the important messages of workforce development, international leadership, job creation, things that would resonate more with the senators and representatives. And so I was missing that aspect of the science that I had studied for so long. And so I started trying to think, is there something else that I could be doing that would still be in the policy sphere, but we'd be looking at that a little bit more? And that's when I found the position at the National Academy of Sciences, doing that, now focus a bit more on science, but still being able to talk about the importance of science and to Congress, to the funding agencies, just connected in a slightly different way than I was before. So all of that is to say, I've been faced with challenges trying to figure out what's going on, trying to figure out what these next steps are, really doing hard analysis of myself, talking with people to try to figure out what it is that I want to do. But I had the tools to actually be able to figure that out, whether it was connecting with mentors here to be able to ask them very specific questions or have them recommend me to certain things. And then all the different thought processes that I learned from my 2 different educations here and other stuff along the way that had built up to allow me to adapt to the different roles that I was then playing. And by the way, in case you're wondering, I was also able to explore that dance side of me in DC as well. I was able to perform at the National Academy of Sciences before I worked there, actually. Where this was the first time that I really experimented with a much deeper integration of science and dance, where I actually said, let me create a dance based on some principle of science and mathematics. And so if any of you have read Tom Stoppard's Arcadia, there's a bunch of math and physics in there, and so I used one of the concepts in there to build a dance around, and had 2 thankfully willing dance friends that helped me do that. And the cultural programs of the National Academy of Sciences is specifically a part of the Academy that looks at the connection of science and art. And so they thankfully sponsored us to actually perform this in one of their buildings. And then this past year, Hickson Dance, the company that I was dancing for in Columbus before I moved to DC, I've still been affiliated with them. I actually helped them put on a show this past April that was all about that was a connection of science and dance. There were 2 dances that were made that I helped, that I was the collaborator consultant on, that I helped them make. One that was influenced by quantum mechanics, quantum entanglement, and the other one that was about galaxy collisions and other sorts of life collisions, thinking about those different aspects and weaving them together. It was a very fun process. And so while I haven't specifically been physically dancing as much, I've been able to create things in that way. Sometimes it's been a little bit more difficult in the last couple of years to be able to integrate that, but I've been really trying to do that. And that's because that's part of me. And as I mentioned before, I want to be able to explore those different aspects of me, and I'm glad that Ohio Wesleyan could let me do that way back when, and could therefore encourage me to keep on doing that. So I'm not a professor here anymore, but I do have some lessons from Dr. Mack that I would like to leave you with tonight. And basically, the first one is be okay with these big questions about life and about what it is that you want to do. Don't be afraid to reanalyze things. Don't be afraid to talk to people you trust about it.
because it can help refine you, put you on a better path, figure out what it is that you want to be doing, figure out what is best, what is best for you. I would not be where I am if I didn't have all the different aspects of the education that I had here contributing to allow me to have the skills that I have. So please let the other aspects of the education you're getting here influence what it is you're doing. The writing from this class, the communication from this class, the science from that class, the artistic aspect of a different class, all those different parts. When you have the classes that you need to take outside of your major, think about them as an opportunity for you to learn something new, to enhance what it is that you're focusing on, or to just have fun and explore a different side of you that you haven't been able to explore in your chosen major. But take those outside classes as that kind of opportunity instead of saying, oh, I have to take another class, let me scan through the catalog and try to figure out what's going to fit in that spot. Okay, so I would encourage you to do that. Find ways to pursue those parts of you that you aren't directly accessing in your chosen major, in your classes. Find some way to connect with people on campus that are interested in that sort of thing that you're interested in, so that you can explore that aspect of you along with the rest of your education. That's been an extremely important part of me, to be able to have that creative and performing aspect along with the science and along with the policy, which has totally influenced how I've been able to communicate my message across to senators and representatives and to scientists to create that video series that I had. They've all come into play in that to make me better at what it is that I'm doing. And value your Ohio Wesleyan mentors, because they want to see you succeed. They want to help you, they want to advise you, they know a whole lot, and they can really help you out. So don't just value them while you're here, value them once you leave too. They're gonna wanna see you come back, they're gonna wanna talk with you, they're gonna want to see how you're doing, and if they can give you some advice, they would love to do that, because that's part of what this university is. And as I said, I'm really happy to have had 2 educations here, not just my undergrad, but then also the time here as a professor, and I could not be more thankful for that, for helping me get to where I am today. Thanks.
Thank you very much. I can't imagine a better kickoff for this part of the Sagan series. We have some time for some questions. I am going to ask, though, that if you have a question, you wait for me to bring the microphone so that everybody can hear.
Hello, my name's Sam. I have a question about something interesting that you mentioned. So you mentioned that you were able to coach some physicists to get ready to talk with senators, I believe?
Yes.
Okay, so I wanted to know how much fun that was.
You know, it actually was fun, because first of all, I had to get the physicists confident in themselves to be able to talk about those certain things, because most scientists are used to talking about their science and that's it. And so it was fun for me to be able to say, no, you please think about how you might be able to talk about it in terms of this. Do you have a student that you've worked with that might have benefited from this? Are you connected with another part of your department? Is there other collaborations you're involved with, or things like that? And I started to help broaden their mindset for what their research was and how it was affecting things, and then kind of tease that out of them. And then they realized, oh, wait, I can talk about this. Oh, and I didn't tell you that I have this student that went on to do this, and who wouldn't have done that if they hadn't had this summer research project that was funded by the National Science Foundation. Like, yes, say that specifically. So it actually was fun to just talk with them and hear their stories, because it really was about having them talk about their personal stories. In science, we don't deal with anecdotes so much, but in policy, anecdotes are a lot, because the senators' representatives want to hear specific stories about people that are in their states or their districts. So anecdotes mean a lot to them. So if you can tell your own personal story in a way that really relates to them, they'll pick up on it. So it was fun to actually help tease out those different parts of them to broaden their own mindset for their research.
Hi, my name is Taryn. With the 2020 election coming up soon, what do you hope for from the president in terms of sciences and with your field and what you're hoping for them to do and to say?
So what I would hope for is for someone to say that the national picture of science funding is important and needed and ideally should be bolstered, and that science plays an important role in things. I would like that person to have the head of the Office of Science and Technology Policy be a cabinet level position, so that you actually have someone from, if not specifically in name, but then basically in understood importance, so that you actually have someone who is directly feeding the president that scientific information. One thing that we've seen in the past couple of years has been, in the overall picture of trying to shrink the budget, trying to do that across the board, and not seeing where that will detrimentally impact science funding, and then not seeing what the benefits of the science funding is right now, and how harmful that could be for what could come next. So basically, the shorter answer to your question is support science funding, try to increase it instead of trying to hold it back, and then really value the scientific expertise that is around that in order to influence the policies that you're putting forward.
Hello. I was wondering what you think the biggest challenges are in communicating science to either policymakers or the public.
That's a good question. So for communicating it to policymakers, it's really about how does this affect me if I'm a Senate representative? How does this affect me? How does this affect my state or my district? So you can't try to excite them with the wonders of science. You have to talk about how you're going to get a specific benefit from doing this science, whether it's impacting the students, whether it's impacting the local community, if you're setting up a connection with a local business, if your results are actually going to be changing policy in some way or affecting health, things like that. So you have to, the challenge is if you can look at the senator or representative's interest, trying to see how a specific science area can relate to that, and then trying to make that tie-in, because then you'll have a much better chance to convince them to back you. Sometimes they already do, and it's just a matter of reinforcing that, but that's the biggest challenge for that. For the public, I think the challenge is to not get too detailed so that you don't end up having people get lost too quickly and lose interest. If you can keep the excitement going and talk about the kind of big picture of the science, then I think you can draw them in and then they'll want to learn more of the details. But if you overload with too many details, then people in the general public will gloss over. They will be more interested, a lot of them, I shouldn't say all, but a lot of them will be more interested in the excitement of the science as opposed to looking for a specific benefit. So, does that help answer?
Hi, my name's SK. This is a clarifying question, and I'm sorry if you mentioned this earlier.
Oh, please, please.
So you said that at your current job, you create conversations between scientists by bringing them together.
Yes.
What requirements do these scientists, what
That's a good
credentials
Yeah.
do these scientists need to have? What,
Yeah, that's a really good question. Who gets involved in these conversations? That's a really good question. So these committees are formed under the umbrella of the national academies. And so you pick someone to be chairing a certain study, chairing a certain report, and you look at who has good credentials in the field to start with that. So who is an expert in certain areas of the science you're trying to investigate, and see different people that might be involved. Just kind of start from that spot, from that leadership position. And then you think about who else might be good to contribute to the discussion. But they have to have a certain amount of credibility in order to do that. So as a visiting assistant professor here, I would not have been one of those people. But if you're a more established person who can really contribute their expertise, then that's seen. And then you can start connecting people that are a bit more experts in their fields to address those issues. So there are people that are elected as members to the National Academy of Sciences because they're recognized as leaders in their field or having made big advances or big impacts. And so we try to involve people from that as much as possible. Now, there aren't a gigantic ton of them in certain areas, and so you cannot just have the committee of the National Academy's members. And so then you go outside and look who else has been leading NASA missions and really understands what it means for that to go, for all the different details to go into it, or leading important studies, or involved in other committees or other discussions. So people that really understand a bit more about what goes into it all. That's a bit vague of an answer, but I hope that gets a little bit of the answer across.
Greg, could you add that point you made earlier about people who aren't too connected to particular projects? The neutrality?
Oh, yes. So we also had to make sure that there aren't conflicts of interest that could come about. So we don't want to have people on a study that will actually be advocates for a certain project. If you're trying to assess the lay of the land, like say for example with Astro 2020, and see what are the important ways forward in the next decade, and you have someone who's leading one of the big missions that's up for consideration, you don't want to put them on the steering committee because they will just be a voice for their, well, maybe not, but it's likely they could just be a voice for their big project. Or it could be perceived as that by the community. And then there's questions about the validity of your study. And so people have to know what's going on, but they can't be in those positions. You need to have a balance, basically, for that.
Hi, my name is Colin. So right now there are climate strikes that are being held all over the world, and for good reason. But the problem with that is that it often becomes more about a spectacle, and you kind of lose sight of some of the more, the nuances of a lot of those issues. And so, my question then is, in a time of such urgency, especially when it comes to advocating for better policies, especially for the environment, how do you keep the focus on specific aspects of an issue without letting them get drowned out by the headlines, right? Because there's Greta Thunberg, right, and she's she's really been making a lot of headlines, but that isn't always what people talk about, and so you're always kind of losing that focus. So, how would you, especially, learning how to talk to different people, especially senators, how do you, keep those details and keep the importance of those details kind of alive?
That's a really good question. And if you're talking about having individual conversations with Senate officers or representatives, one way to do that would be to make sure that you come into it not from a confrontational standpoint, but more of a reasoned standpoint. Present your information in a way that you think will relate to them and be ready to have a conversation, instead of coming in and railing on them and saying, why aren't you doing this? You should be doing this, because then everybody gets defensive. So one way to do that in general, to have those conversations, is to come at it from that standpoint and to arm yourself with credible information that you can get across in an easily packaged form, meaning a clear message that you can talk about. So if you are talking about things from, so that's what I would say for individual conversation. If you're talking about stuff from what the National Academies would be doing, then you could put out a report, a statement, something that is a unified statement from a number of experts in a specific science field, like climate science, to say that this is bad. You should do this. Please take this into account, as a way to actually have a collective set of expertise that can have a recommendation. I'm not quite sure if I'm answering your question for how to come at it from a different standpoint than the headlines. Do you want to ask it again?
So I guess like I know that there's like a climate strike even like tomorrow, but not everyone there is going to be capable of churning out a 300-page report, right?
Oh, right.
There isn't like a statement of aims that everyone has going into that. What, like, I guess, how do you, yeah, I don't really know how else to ask it. I'm sorry.
So I guess one thing I think I might say is that instead of, and this is where it was impactful to be working on behalf of the American Physical Society, because we were able to get a group of physicists together to all talk about an important message. So, and that way it wasn't just one person talking about what they thought was important and one person talking about what they thought was important. It was a unified message, and it had the backing of that organization. And so that was able to cut through a bit more things than you might have otherwise. And so while climate strikes and things like that are going on and making a spectacle, if you had an organization like the Union of Concerned Scientists or the American Meteorological Society that come across with a unified message, that you can actually, that you as an individual can take that message and take it to someone and have the backing of that organization, that helps cut through. Does that help make sense? Okay. I hope that answers a bit. It's a really hard question because it really depends on who's listening and what they will really resonate with.
Is there any importance like placed on, like I get that you want to like do experiments for like things that haven't been answered, but is there any importance on like funding studies that are like repeats of former ones to make sure they're actually like reliable?
So yeah, this is actually an important issue right now. Government, because of the budgetary constraints, funding agencies don't like to fund repeats of studies. However, some studies, especially in certain areas of science, are finding you can't reproduce them. And so there's a need for people to repeat the studies to see if what people did was actually correct and actually viable, but then there's the problem of you can't get the money to actually do it. So there is value in doing it, but it's a big piece of tension right now for how that would work. Personally, I think yes, you should be funding certain of those activities to be able to reproduce other things to make sure that the scientific study is actually correct. But with limited resources, the funding agencies had to make tough decisions, and that's why they usually go for what's new and different as opposed to repeating old things. But as I said, there's lots of discussions right now and have been for the last number of years on reproducibility of research, because people are finding that some studies just don't work out when you do them again. Or in some instances, there's some scientific misconduct that's gone on, and you end up with results that aren't real because someone cheated on their data and didn't do right things or falsified stuff. So it's needed sometimes, but the problem is how do you actually fund that and where does it come from? And the agencies are wrestling with this. The Office of Science Technology Policy is wrestling with this, so it's a big question. Any other questions?
I have one.
Yeah?
What advice, what concrete advice would you give current OWU students who are sort of staring into this looming future? What should they do while they're here? What should they be paying attention to?
So concrete advice on what to do to get ready for what's next.
The world, yeah.
Yeah. So beyond stuff you're doing to be successful at your major and thinking about where that might lead you, the first thing is talk with your professors, explore with them different options. If you're thinking about going down a certain path, check with them and see what their connections are with that path, what their opinions are about that path. They might have some information for you that would be really useful of saying, oh, you want to do this? You need to take this class. Or you need to talk to this professor in this department because it actually lines up really well. So having those conversations is going to be really important. And being able to, if you have an idea of what it is that you want to do next, but aren't quite sure how to tackle it, then you might, in a related way, find some classes that speak at different aspects of it and see what else you can learn. But I think that the most concrete thing is to talk, to actually ask questions of your professors and mentors, talk with them about different aspects of things, what are options, what they think you might need in order to pursue what it is you want to do.
You're a wonderful advocate for the importance of talking and communicating. Thank you very much for your time, for coming back, for coming home, and let's thank Greg again. Yep.